in this case, and the exam is going to do the same thing. They're going to tell you at this point, every unit is sectioned off on the exam. Okay, so when it's precision measurement, it's all precision measurement, big title, you know which unit you're in, you're not guessing. And it's they're going to tell you do not round, okay? And so keep that in mind. So let's talk about some terminology. So that's a little annoying, the terminology, but after we've settled this, we can just go ahead and do the examples, okay? Accuracy. Accuracy refers to how close, watch this, how close a measurement is to its target, value. What are you talking about? Okay, let's see if you can follow this. There's a certain temperature of this room. Nobody can deny it. It is what it is. And if I were to use this device, can you see that? This is a thermometer, right? There. So right now, if I point it at this piece of paper, it's 22.4 degrees. Is there a chance that it's not 22.4 in this room? There's a chance. There's a chance that it's 22, okay? And this thing is saying 22.4. So accuracy is how close you are to the actual what it's supposed to be, okay? That's what we call accuracy. So if you grab a piece of wood and it's 5 inches and you measure it with the measuring tape and you measure 4 and 7/8, and you're like, well, you're not, it's supposed to be 5, you're not close. So you could be really close, you could be bang on, but how close you are to the target, that is what we call accuracy. So I would say, honestly, I'm going to highlight what I would like you to have on your study sheet. And shorten it, okay? Accuracy, how close to the target. That's it. How close to the target. To be accurate, a measurement value must be as close to the real value as possible. If you claim to have measured something accurately, someone should be able to repeat the process and get the same value. Okay? Somebody should be able to, hey, I measured the football field. Go ahead and measure it. If somebody else can take your measuring tool and repeat it and get the same, you're accurate. Okay? So, to be accurate, we use a standard unit. Okay, standard unit, that's important. So to be accurate, we use a standard unit and we use an appropriate scale. So for example, you're not going to use kilometers to measure the circumference of a baby's head, right? You wouldn't use kilometers for it. It's just ridiculous. You wouldn't use centimeters to measure the distance between Earth and the moon. It just wouldn't work, right? So that's what we mean by scale. It has to be within reason, okay? Standard units. Standard units are units that anywhere in the world you mention them and people would know what that is. So, right, miles, kilometers, kilograms, milliliters, ounces, feet, teaspoons, yes, teaspoon, tablespoon, cup. Those are technically measurements, okay? Those are standard. Non-standard is anything that isn't, like using anything on your body to measure it, like your foot, your hand span, your feet is not accurate. And I think you can all figure that one out. If I measure this classroom with my feet, and then you use your feet, we're not going to have the same answer, right? We're not going to have the same answer. Even hand span, like mine is different than yours and so forth. So that's not a standard unit, okay? So this is very important, this right here. To be accurate, you need these two things. You can make it very short and sweet on your study sheet, but they will test you on this. So, okay, like, oh, this is very dark here. Let's brighten this up a bit. Let's brighten up your day a little bit here. Okay. Accuracy can also be affected by improper or careless use of the measuring device. or a damaged or faulty measuring device. I would say this is also important. I tried to make this very concise. I could have given you pages and pages of text. I didn't want that. So I'm trying to make it very... So when are you going to use this? When it's like an explain or justify type of scenario. Okay? And I'll show you later on. So for example, using a cup to measure flour, okay? You should level it off at the top, right? You should not leave it like this, all like this isn't even packed, right? So you don't, this would be an improper use, this would be the proper use. A ruler, what's wrong with this? This ruler is obviously warped, right? Your friend grabbed it while the lesson was happening, they're just playing with the ruler, now it's all bent up, right? It just wouldn't be an accurate reading. So this is what I mean by that. So this first one is depicted here, and the damaged device is depicted here. Okay, so that's, you sometimes have to use words to describe that. Okay. All right, let's keep going. State whether each scenario would result in an accurate measurement. Explain, making reference to the unit being used and the scale. Okay? So every single time I want you to talk about units, right? Is it standard? And scale, is it appropriate? So let's do one together. Using centimeters, is that a standard unit? For sure, right? To measure someone's height, is that an appropriate scale? Yeah, yeah. Height can be centimeters, inches, feet, like all of that is still acceptable. I wonder if even millimeters, I mean millimeters would probably, you'd be pushing it, but they will be very obvious on a test or an exam, we will be obvious on that. So it is accurate. Okay, standard unit, appropriate scale. So in this case, that's all we make reference to. And we're not, right? So how about you try just doing this. Honestly, all you need to do is this. Make a reference about the unit and the scale, and then make your statement whether or not it is accurate. If it fails either one or both, it's not going to be accurate. Okay? So I want you to try those real quick. I'm not going to spend a whole lot of time on it, but I will go over it real quick. Using your forearm to measure the length of a picnic table. Not a standard unit. Right? What about the scale? Scale is actually appropriate. Okay? But not accurate. Okay? You know what? If you just went straight ahead and say, "Hey, this is not accurate because the unit is not standard," that would have been just fine. So you don't have to talk about both every single time. Just tell me why it isn't accurate. Next one, using a meter stick to calculate the distance between two cities. This is standard. Okay, standard unit. But is the scale appropriate? I would say not an appropriate scale. Because you would go kilometers, right? When it's distance between two cities. So therefore, not accurate. a ruler marked in millimeters to measure the width of a textbook. This would be standard. And scale is also okay. Okay, scale is appropriate. It's a standard unit. Therefore, this would be an accurate measurement. Using your stride to mark off a volleyball court, I would say this is not standard. Scale is appropriate. Scale is appropriate. But because this fails, not a standard unit, we would say not accurate. The measurement is not accurate because you couldn't repeat it. So for us in this particular unit, that is what we mean with accuracy. Okay. What about F there on the back, next page? I'm just going to do F with you. Tablespoon to measure the amount of sugar required for a cake. Standard. For a cake, right? It would be okay. So standard and appropriate. Therefore accurate. You could send this recipe to someone else and they should be able to redo it, get the same outcome. Okay. Oh, this is, you know what? This is actually, I'm going to use this to help you out here when you get something like this. Mayer used a measuring tape to determine the width of a wood piece. It was supposed to be, right, this is our target. It was supposed to be 4 inches wide. Yet she recorded 3 7/8. Why might this be? Explain your knowledge of accuracy. You're going to go to your study sheet and you're going to be asking yourself, what affects accuracy? Right? Well, it could be improper or careless use or damaged or faulty measuring device. So that affects accuracy as well as the scale. Okay? But we know that the scale is appropriate because the piece is in inches and we're using inches. Right? So that's not a problem here. And we're using a standard unit, so that's not a problem here. So what is the problem? It could be, right, option 1. It could be that the tape measure, right, measuring tape, write this down so you have something when you flip through your note. Measuring tape was damaged. Example, some markings were missing. Some markings were missing. Okay, like if you use your measuring tape a lot, you will notice that it wears out, right? Those numbers start coming off. The markings start kind of blurring and scratching off. So that's one option. So I know it sounds kind of cheesy, but that's what you're going to do. Sorry, I was way off there. Sorry, guys. Or option 2, talk about improper use, right? Maybe she did not make sure to have the tape flat against the wood, right? Maybe it wasn't like nicely flat against the wood. Maybe it was warped in any way. So talk about not using it properly or something like that, and then you get the marks there. Usually it will say justify. I did say explain here. That word, okay, it means don't just give me one word answer. State is okay, but if it's explain or justify, they want something a bit more than just that. Okay? So let's talk about the next part. So we talked about accuracy. Now we're getting into what is more math related, okay? To be honest, you're gonna do very little like high level math here. It's just gonna be concept based. Precision and uncertainty. Folks, from now on, every measurement has these two, okay? So what is precision? Precision refers to the smallest increment on a measuring device. I'm going to ask you to highlight this and add to your study sheet. That is the best definition. Okay? Another way of saying this is that the precision is the smallest amount by which a measuring device can go up or down by. I'm going to give this a different color because I think this one you don't really need to have on your study sheet as long as you have the first one. Okay? It's the smallest amount by which a measuring device can go up or down by. Every measuring device, no matter how precise, will have a limitation. Precision essentially states what this limitation is. Precision essentially states what the limitation of your device is. Let me tell you, every device you see out there is limited. Okay? For example, let's go back to this. Can you see that? Yeah, you can see it, right? It says 22.2. Is it possible that it's 22.3 in here? Is it possible that it's 22.25? It is possible. But this thing cannot give me more than just one decimal place. It's limited to that. Okay? So that's what I'm talking about here. Next, a different color for this one. This is the other. These ones that go together, like precision goes with uncertainty always. Uncertainty is basically due to the fact that every measuring device has a certain limitation, there's always some uncertainty. We're not quite sure if it's exactly what we see on the measuring device. All measurements have a potential to be off. Regardless of the precision of the measuring device, at some point you have to round up or down. Okay? At some point you have to, that device is rounding up or down. I can guarantee you that. This is called the margin of error. Okay? And here is the important piece. Uncertainty is always half of what the precision is. Remember that. This should be on your study sheet as well. And here it is. These are all going to be numbers. Right now we just have terms associated with them. But to get the uncertainty, you take your precision, slice it in half. And you have the plus or minus in front usually. So example, right? The uncertainty could be plus or minus 1 millimeter. Meaning whatever you measured, you could be off by a millimeter. Either it could be bigger or smaller than what you measured. And so you're expected to state the precision measurement given a picture, an actual measurement, or words. Okay? They could give you any of these and you should be able to come up with the precision and the uncertainty. Okay. Please pay attention to this part. This is where it all comes together, and I can guarantee you there'll be a question like this. We look at this device right here. We noted that it's milliliters. Okay, units are very important in this particular chapter. What is the smallest amount that this thing appears to be going up by? 10, right? So you go plus 10, plus 10, plus 10. It also goes down by 10, right? If you were to go from 40 down. But what remember is it's 10, right? So what's the precision of this particular device? 10 milliliters. Just like that. That's the precision of this thing. You're like, I know what you're going to think. Let me see if I can read your mind. Mr. Dirksen, if the water, if I fill it up between 10 and 20, I know that that's 15. Don't think like that in this unit. Okay? Pretend like this thing can only go as close as 10 milliliter at a time. So if the water, listen carefully, if the water fills up and it goes to just over 20, this thing would read 20. But if you fill it up even more and you get closer to 30, this thing would measure 30. It's limited to 10 milliliters at a time. Okay? So if my precision is 10, what's my uncertainty? I could give you some money here, but I won't. What do we do? We take precision, we divide it in half. So in this case, it's 10. Slice it in half, divide it by 2, and you get 5 milliliters. So there you have 1 mark for each. 1 for this, 1 for this on the exam. Just like that. It's based on the picture here. And I'll make a note here. Let's go an arrow here. I need you to understand what just happened. I need you to understand what the 10 represents. The smallest increment of the beaker is 10 milliliters. Okay, that's what you're saying there. Okay. And you might think, like, well, how does accuracy, how does that factor in here? Well, if I use this thing, would I be accurate? Well, the scale is good, right? No, sorry, the unit is good, milliliters. And now it depends. What are you using it for? Are you using this to fill up a pool? That'd be a terrible scale, right? Using this to fill up a pool, terrible. Or to measure how much water is in a pool. So it depends. Accuracy depends on the scenario, okay? How about this? Actual measurement. What is the precision of this? Let's put a pause on there. What would be the precision if I have a scale and my scale says this, like right now, I'm not stepping on it yet. I'm not stepping on it yet. This right here where my pencil is, that is where the smallest increment can happen, right? So this has a precision which is 0.01. Same here. You focus in on that last decimal, okay? That's where the precision is found. Smallest decimal. Make an exclamation mark there. So that's what we base it on. So watch this. Precision is going to be 0.01. Always a 1 where the last digit is. Centimeters. Okay. So these ones are a little trickier because you don't have that diagram to go by. But that's what this is saying, that this measurement could go up by 1 at the end here, so it would be 55.28. Or down by 0.01, which would be 55.26. All right, guys, that's what's happening here. So what's my uncertainty? 0.01 divided by 2. Use a calculator if you must. Okay, so you grab this, 0.01 divided by 2, you get 0.005. I'm going to tell you a little secret that if uncertainty is just stated on its own like this, you don't need the plus and minus in front of it. But I do like it because later on, when you tack it onto something, it needs to be there. So I'll just start doing that. Precision, uncertainty. Let's use a highlighter. Where did this 1 come from? It came from that spot here, the second spot. So some students, they want to say, oh, it's 0.07. It's not 0.07. Where the 7 is, that's where the precision is found. It's right here. So it's 0.01. Anyways, let's keep going. Ruler is marked in, watch this, ruler is marked in, ruler is marked in half-inch increments. What does that mean? Marked, watch this. Are these markings? Yes. So right there, you got to imagine a container that's half-inch increments. So watch this. Precision is half an inch. That's what it is. just like that. I think this one is easy. Like if it says marked and whatever, just take that and just, that's your precision. What's my uncertainty here? You guessed it. Take that, divide it in half, 0.5 divided by 2, plus or minus 0.25 of an inch. That's my uncertainty there. Can I do one more? I feel like you need one more of these here. So let's cut it here. If I gave you that, what's the precision? The precision is found in the, this is a decimal, right? So 1, 2, 3, third decimal place. So you need to make a decimal where the third decimal place is a 1. Okay, it's found right there. So this is your precision. Is this thing precise or what? Super precise. This is like this, the more decimal places, the more precise this thing is. Okay? Uncertainty, 0.001 divided by 2. Come on, guys, the divided by 2 part, I hope you get that part. Because even if you get your precision wrong, you can still get the uncertainty right. 0.001 divided by 2. Whoa, how many zeros is that? 3 zeros and a 5, okay. 1, 2, 3, and then a 5, and make sure you have units everywhere, because they are going to give you units every single time. Okay, so this is another one where you get an actual measurement, and I can see that the province does something like this, and some of you might be tempted, like, oh, there's no precision, it's 0, right? No, it's not. Focus on the decimal places, not the actual value, okay? Whew. I'm getting tired explaining this, because it is a bit of a weird unit, I get it. I'm trying my best here to help you out. You still have to pay attention, okay? I designed this a certain way so that we kind of build on what we know. What would be my precision here? And you might think it's 100. No, it's not 100. What am I going up by from marking to marking? 50, right? Like sometimes, most of these you can just look at it and be like, this is 50. Oh, it's almost, this is 50, right? Could you see that? Can you see that it's 50? Okay. So precision is 50 what? Milliliters. And uncertainty, can we do mental math here? I think so. 25 mLs, right? And there's a plus or minus there. So what you just found out is that this thing can measure to the closest 50 milliliters, and you can be off by 25 milliliters either way. Okay? Can I just tell you something? Imagine that this thing is an electronic device that you filled in, but you couldn't actually see where the line is, like where the fill line is. You couldn't see it. The thing would tell you it. Okay? So guess what? Everybody tell me, if I fill it up to here, can you see that? What would this device spit back at me? 100 or 150? It would say 100. If it is over here closer to that, it would say 150. Plus or minus 25 milliliters, right? We always imagine that we're off by a bit. So that's where this unit is a little weird, okay? What's the precision on this one? Focusing on the inches. 6 feet, 2 inches. So the precision here is just 1 inch. Like that's the smallest increment or the smallest decrease that you could possibly have. Like we're imagining that if this person was a little taller, it'd be 6'3", and if it was a little shorter, it'd be 6'1". Okay? So that's what we're imagining here. Uncertainty is plus or minus half of an inch. Hey, do you like fractions? No problem. I got you. Right? Fractions are okay. Like if you would rather use fractions in your answer, that is just fine. Measuring tape markings that have markings of a quarter. Hey, markings, right? That's what where it's at. That's what precision cares about. So a quarter of an inch. Watch this. You don't like fractions? No worries. Turn that into a decimal. As soon as you can, turn it into a decimal. What's my uncertainty? What's half of 1/4? You did it the decimal way, but if you did it the fraction way, did you know that it's literally you multiply the denominator by 2? Like you're having smaller pieces, like you're halving all those quarters. So it's actually 1/8 of an inch. And if you hate what I just did, I got you, right? Just take this one and divide it by 2. What was that? 125, right? Yeah. So either way, you want fractions, you want decimals, but I can tell you this, fractions are always going to be quarters, eighths, 16ths, 32nds, like it's measuring stuff. So that's your measuring tape, right? Equivalent. I just said always, right? I take that back, because the province, you never know what they're going to do. 1/3 of a cup, I don't know, right? Something is marked in thirds, then it would be 1/3, and then 1/6 would be the uncertainty, 1/6. So basically you multiply the denominator by 2. I'm going to stop talking here, and I made a bunch of these. You're going to skip page 7 for now. 7 I don't want you to do, you're not ready yet. But there's lots and lots of examples, real world examples. I went all around my house and I took pictures of various things. Some are blurry, and I get it, it's not the greatest. But basically all the way to 14. I know you're going to omit 7, right? Omit 7 for now. But they're all very doable. Every single time I'm asking you for precision and uncertainty. Precision, uncertainty. That's all I'm asking you every single time. Okay? So if you could do that, rest of the class, you don't have a whole lot, but you can probably get like 3 of them done today. And then we'll continue with this tomorrow. Thank you guys. I know it was a long lesson. You were great though.